Let's solve this initial value problem. Now we have been given t y prime plus 2y should be equal to sine t over t. Now from this differential equation is a first order differential equation, and we have to write this one in the standard form by dividing through by t. So if I should divide through by t, I'll get y prime plus 2y on t should be equal to sine t all squared t squared sine t over t squared. So that will be the first thing to do. It means that our integrating factor would be the coefficient of y, that is y integral of 2 over t dt. That is our integrating factor. If we simplify this, we will get t squared. I believe we can all do this one. If you want to integrate, you have to first bring the 2 out and integrate 1 over t dt. And we know that the integral of 1 over t will give us the natural logarithm of t. Then we can also say that applying the laws of logarithm, we have ln t all squared. Will cancel this, therefore we are left with t squared. So that is our integrating factor. That is our integrating factor. So the next thing we have to do is to multiply through by the integrating factor. So to do that, we are going to get t squared will multiply this whole thing, which is y prime plus t squared will multiply 2y over t. Then that should be equal to this, which is going to be t squared will cancel out. So let me just write first t squared multiplied by sine t over t squared, and we can see that we have t squared y prime plus, when we cancel out, we will get 2t multiplied by y here, then should be equal to sine t. Then we know that this follows the product rule, which when simplified will be equal to the integrating factor multiplied by the dependent variable all prime should be equal to sine t. So that is it. From here, we need to find a total derivative of this. So let me rewrite this one. Let us integrate both sides. I integrate here and integrate here with respect to t. So if I do that, I'm going to get t squared y should be equal to, if I integrate sine t, I'll get negative cos t plus a constant c. Let us take a total derivative of this one by taking this to the left hand side. I will get t squared y plus cos t should be equal to a constant c. But remember, if I should differentiate this one, if I take a total derivative of this, then it will be equal to 0. So This is what we call the total derivative, and the function inside here is called our potential function. The potential function is always expressed in a functional notation as a function of t and the dependent variable y of t. That is the potential function. It is always equal to a constant, but if I should take the derivative of it, then it is equal to 0. It means that my potential function is equal to a constant c, and that constant is what is in the bracket here. So I can write as t squared y plus cos t, which is the potential function, equal to the constant c. Then I can divide through by t squared. If I do that, I'll get y plus cos t all t squared. Remember, this t is the angle, should be equal to c over t squared. Then by grouping like terms, I'll get y should be equal to c over t squared minus cos t over t squared. So this is our equation, or that is the solution. It is always expressed as a function of t. So that is it. We have been given an initial value problem, that is y of pi on 2 should be equal to pi on 2. It means that my y here is pi on 2 should be equal to c is unknown, so c over t squared. So that is going to be pi on 2 squared, then minus cos pi on 2 all divided by pi on 2 squared. Now we have pi on 2 here should be equal to c over pi squared on 4. Pi squared, let me write it well, pi squared on 4, then minus, remember cos pi on 2 is 90, cos 90 is 0, and 0 divided by any number is 0. So finally, I have pi on 2. If I reciprocate this, I'll get, I have pi on 2 should be equal to, this gives me 4c on pi squared, or let me write it this way, because you are making c the subject. Since you are making c the subject, this one is already 0, so I can just take this one off. Then I have cross multiply. So if you cross multiply, when you cross multiply, you will get c to be equal to pi on 2 times pi squared on 4. So I have c to be equal to pi times pi squared will give me pi cubed. All on 2 times 4 is 8. So that is my c. So I have to go back to the general solution and substitute it inside. So I have y of t to be equal to my c, which is pi cubed The 8 will come down to multiply the t squared here minus cos t over t squared, and that is the final answer. That is the final answer.